Hello, guys. So this is a continuation of lesson 2 for laboratory preparation of gases. So if you recall, the last class we had, well, we looked at the reaction between an acid and a metal. The reaction between an acid and a metal. Yeah, because the setup to prepare hydrogen gas indicate that an acid must be reacted with a metal, and that's how come hydrogen gas is produced. And in our setup, we're using hydrochloric acid and zinc. And I said in exam, they can give you a different acid. So it's important to know how to recognize acids so that when you look at the setup, you know that this is an acid. You should also be able to know how to recognize metals. So if you know how to see acids, how to see metals, it will be easy for you to identify what gas is being prepared. Hello? Hello?
I said,
So you're okay with the reaction, right? The product, you are okay. The only thing we were left with is to balance.
yes.
So let's see how we balance that. All right, so um I said balance hydrogen and oxygen first, isn't it? So now, um, you see, hydrogen is 2 here. So I want to make here 2. Okay. So hydrogen has become 2. Now let's balance oxygen. Yeah, hydrogen it's not found anywhere again. At the this side is reactant and this side is product. Hmm? So there is no hydrogen there. So if here is 2 and here is 2, it's fine, right? Then let's come to oxygen. Oxygen is 2 times 3. You see, oxygen is 3 here, right? So 2 times 3 is what? 6. Now, oxygen 2 is here, 2 times 3, which is what? 6. So oxygen is also balanced at the product side, at the right-hand side, guys. Oxygen is 2 times 3. Hello.
Yes, sir.
Let me tell you one secret. If when you are joining them, you see, at the product side, when you are joining the compounds, if you don't marry them properly, when I say marry them properly, if you don't interchange their valences, so that the subscript of 2 will come, and let's say here is 1, you'll be struggling balancing. So all the time, make sure you merge them properly. Now that hydrogen and oxygen is balanced, everything will be easier. The other element left is nitrogen. Nitrogen is 2. You see, the 2 outside here covers everyone. So the nitrogen is 2. There is no nitrogen here, right? So let's come here. Here to how many nitrogens do we have? It's in a bracket. 2 is outside the bracket, meaning nitrogen is what? 2. Then now what is left again is magnesium. It's 1 on the left hand side, it's 1 on the right hand side. It's balanced. Any question? When you react
Sir.
an acid with a metal, you see hydrogen gas is produced. Yes. Any question?
Yes, sir.
Go ahead, my darling.
So the speaker was going off, so I went for the charger. So I don't
Oh my
understand.
days. So you never told me. You made me speak to the end before notifying me.
I'm sorry.
So meaning everything I said, you never heard me.
Yes, sir.
But how can you people do this? So which part did you get lost?
So the beginning of the equation, like when you were balancing the equation.
This is ridiculous. You wait for me to speak to the end before notifying me about that. When you could have just come in midway. And who does that? Channel 3.
Oh.
MJ Channel 3. Okay. I said balance hydrogen and oxygen first. So hydrogen is 2 here. So I'll make here 2. Before we close the previous lesson, I told you if you balancing and you want to add moles, don't the only place you can add moles is outside, not like underneath. No. So now hydrogen is 2. Let's balance oxygen first. Oxygen next. Oxygen is 3 here, right? But 2 is outside and they multiply. So that'll be 6. Now, oxygen 2 is 3 here, but remember there is 2 moles here. It's HNO3 and 2 is there, right? So 2 multiplies, so it's also 6. So it's cool. Now, once hydrogen and oxygen is balanced, the rest becomes easier for you. Nitrogen here is 2. The 2 affected 2. Nitrogen here is 2, 2, 2. You see, it's 1 inside, but 2 is outside the bracket, so it's 2. You see. Yeah. Then what else? Magnesium is 1. We are done. Any question, please? I've
Say
got, uh-huh.
the nitrogen and the oxygen in the brackets. The three affects only the oxygen.
Yeah, but the 3 is just in front of oxygen. You see,
Okay.
so it's for oxygen. That too, because everything is in a bracket and something is outside the bracket, it covers all of us. So that's the 2. The nitrogen is 2. You get it?
Okay.
Um, I want to give you a different acid. Okay. Now, these are the popular acids you see. If it's not HCl, then it's HNO3, right? There are other acids. You cannot. So, react tetraoxosulfate 6 acid, A2SO4. You are lucky, I told you. It's called sulfuric acid. In exam, in the setup, if they write H2SO4, no, in the set, so sulfuric acid, in the setup, if they write sulfuric acid, sulfur, right? Sulfuric acid to, so let's react it to aluminum. I just want to give you a lot of work. Aluminium, the chemical symbol for aluminum is Al. Can you try this? Or you want us to do it together? Hmm? Hello, guys. Hello. What's going on? So, in exam in a setup, you might be asked to react sulfuric acid to aluminum. Yeah, so the chemical formula for aluminum is Al. The chemical formula for sulfuric acid is A2SO4. Are you listening? So,
Yes, yes.
how do we react? Do you want us to do it together? I think we should. Okay. So, yeah, help me establish the equation. Let's do it one after the other. It will be what plus what? But before that, it's an acid. The word is even telling you acid, right? Aluminium is a metal. After this, I'm come to show you how to find metals, how to find acids. But aluminium is a metal. Are you listening? So an acid with a metal, you know hydrogen gas is going to be produced. So if I give you a diagram, and in the diagram we are pouring sulfuric acid to aluminium, and you know aluminium is a metal, then you know that the gas that is being prepared is hydrogen gas. Hmm?
Chromium as sulfur.
Yeah. So let's start. Help me establish the equation.
The aluminum plus sulfur.
Hmm. Oh, no, no. My brother, start speaking in letters. Don't tell me aluminium for me to do it for you.
AL.
Okay.
AL.
But can we start with the acid first? You are not wrong. You are not wrong, but can we start with the acid first?
So,
Sure, but you're not talking.
H2SO4
H2SO4. Mm-hmm.
plus
AL.
Al
Mm-hmm.
Bottle.
plus
Mm-hmm.
Al.
Now, at the product side, what are we to marry? The cation, right? Which I said is the metal. And the anion. What's the anion here?
SO4.
Yesterday, I never defined radicals for you. No one asked.
So you said you define it, but not now.
Okay. All right. So let's go. So it's going to be Al. Mhm.
SO4
Let me define it.
bracket.
Let me define it now. Okay. So because we have a lot ahead of us, radicals. So they are group of elements which stays together as a charged unit. So they are a group of elements which stays together as a charged unit. Yeah. Radicals are a group of elements which stays together as a charged unit. So example, they are a lot. So SO4, right? Their charge is 2 minus 830. Their charge is positive. Hydrozonium. Hydroxyl OH. Their charge is minus. NO. Their charge is negative. Yesterday, I seem to have written a number of them.
Yes.
What else again? Okay, you can refer to yesterday's note. PO4. Mm, it's 2 minus. All these are radicals, by the way. So we said H2SO4 plus Al, right? When you're done
Yeah.
writing, let me know so that we can carry on.
So you're done. You're done.
Okay, so it's gonna be we're gonna marry Al and what? SO4, right? Then now
Yes.
let's consider their charges so that we can marry them all. So this one I'm just feeding you, but going forward you do it yourself. What's the charge for aluminium?
Aluminum. Like,
Mhm.
like one.
Actually,
Like
it's plus
one.
3, but don't worry, it's fine. SO4 you must know because it's a family, you know. What's that? The charge of aluminium is plus 3. That's why you normally see us writing Al3 plus. Don't worry, we are getting there. You know how to do this all by yourself. That's what I told you to go and learn. Hmm? What's the charge for SO4?
plus 2 negative, 2 minus.
2 minus.
Whatever it is. The good news is you knowing is 2. So someone should marry them for me properly. Mhm.
Equal to
Let's go for
into bracket 3.
Correct. You guys are becoming wise. Now it's okay. L to right. Oh, you guys are doing well. Oh, I'm coming. SO4. What? 3, right? We are done. Then plus. So now, plus what? In the equation, you dealt with EL and SO4. So plus what? Say that again.
H2.
Then we balance. You get it. And I believe you know why it's H2, right? H is left, but I said don't let it stand on its own. You must write in a molecular form. Balance hydrogen and oxygen first. So hydrogen is what? It's 2 here, right? And hydrogen is what? 2 here. So it's cool, right? Oxygen is how many here?
Oxygen, 12.
It's 12. But oxygen is how many here?
4.
So I think let's balance oxygen first before we go to hydrogen. Oxygen is 12 here.
Yes.
What times 4 will become 12?
4, 3.
So let's put 3 here. So that 3 times 4, oxygen is 12. So 12, 12.
Yes.
You see? Then now, so we are cool with oxygen. So we balance hydrogen. Do you understand? So sometimes when you are balancing hydrogen and oxygen, you choose to balance hydrogen first and later realize oxygen will give issues. So deal with oxygen first and we come to hydrogen. Yeah. So now coming back at hydrogen, hydrogen here has become what? Who will tell me? It has become what? On the left side, 6. So here is 2. So what can you do to 2 to become 6?
3.
3 to 6. Cool. Yeah, 3. 3 to 6. So we are done. Now let's look at the other elements. So aluminum is what? 2 here, right? So put 2 here, we are done. Then what other element? Sulfur. Sulfur is what? See, sulfur is what here? It's 3. Oh.
Second is what?
You are blind. We'll give you spectacles, my dear. Should we give you spectacles?
Closer.
Sulfur is how many here?
3.
It's in brackets. Outside bracket 3. So the 3 will affect sulfur 2.
Okay.
So it's 3. It's also 3 on the left hand side. We are done.
Yes.
Mhm.
Say,
Yes, I'm with you.
the aluminium and the sulfate acid,
Mhm.
you see when you put this thing, plus 3 and the minus 2,
Mhm. That's your work. Don't do it in your work, okay? I'm cleaning crap. But ask your question.
So it's okay, I understand what I was about to ask.
Good, 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 good. All right. Now, so in exam, the question they will ask you is write a balanced chemical equation. You see, for the reaction in the container, the setup, that's the next question to ask you. Write a balanced chemical equation for the reaction in the setup. You see, so you write the chemical equation, you have to balance it. So expect this question. Now let's move on. So now your concern should be how we should like your concern should be how will I know acids? How will I know metals, right? So for acids, I've given you a number of them, right? So we'll talk about, okay, I even have a video for access on our channel, so go and watch. But of course, examples of acids, so we have hydrochloric acid, HCl, right? That's how it's called, hydrochloric acid. Okay, then we have H2SO4. I've given you the name above. I said it's was sulfuric acid, right?
Yes.
Yeah, sulfuric acid. That's a common name, but the scientific name or the IUPAC name is tetraoxo. We read from the back. Tetra for four, oxo for oxygen, sulfate for sulfur. Tetraoxosulfate. Then six. We use Roman numeral VI. Six is the oxidation number. Okay, is the oxidation number. We calculate for it. Tetraoxosulfate 6. Acid. Acid represent the existence of hydrogen. Tetra 4. Oxo. Sulfate. So this is what the IUPAC what. You see the way I'm writing everything for you. So if you are there chewing your pen, not writing anything, hmm, you receive a divine knock. Okay, that's the IUPAC name. Then I said the common name, because there are questions they'll ask you. The common name is what? Sulfuric acid. Back in the days, there were the common or trivial name. Okay, trivial. Back in the days, they attach like a common name to certain element, trivial. Okay, trivial or common name. Okay, then there's also another acid, HNO3. So the IUPAC name we read from the back. Try for three. Hold on. Sorry, yeah. So try for three. Oxo, right? For oxygen. Nitrate for what? Nitrogen. Then five, representing something we call oxidation number. We calculate. Roman numeral V is what? 5, right? Then acid. Acid for what? Each. So that's the IUPAC name. And if you're interested in the common name, Makawa Hada, who will tell me? Or trivial name, who will tell me? Ubusa. Nitric acid. Yeah, it's nitric acid. So these are some acids you might encounter, right? We also have H2PO4. Hmm? So tetra, we are smart, so bet me a name impo. Tetra for 4, right? Monko. Mo female. Tetra. Yeah, can you be entry? Tetra hmm, zo. Maso swam. Ozo. Uh-huh. P is phosphorus, but can ye? P is phosphorus, but look, sulfur, yeah, a friend BB. So phosphorus, can then tetra ozo. Phos, phosphate. Yeah, record you, mugumenu. Phosphate 6. 6 is the oxidation state, okay? Then acid, you get. Then the
Yes.
common name is called, we a section A question, so phosphoric acid, yeah. So these are the common acids you meet. They are all strong acids. So I'm just listing them now who say we acid. Now let's come to metals. Are you ready? At the end, I'm going with you. You see, I'm wasting all the time to do this. More hard, you. I'll give you an assignment. Let me know when you are done.
We are done.
So when you meet the word trivial, I don't know if I spelled it properly or I'm pronouncing it right, but if you meet the word trivial, trivial means what, like common name. So if they tell you, give me the trivial name for each and all three, you know, right? The common name is what, nitric acid, right?
Yes.
Okay. There's another one, ethanoic acid, but when you go and watch the channel, it's there. Okay, then now let's come to metals. We have to draw the periodic table. Do you remember your first 20 elements?
Yes.
Okay, so we have group 1, group 2. I'm drawing a periodic table. Group 3, group 4, encore. Group 5, geez, no space. Group 6, group 7, then group 8. And group 8. Then we have period 1, period 2, period 3, then we have period 4. You see? Now, so this is how we draw the periodic table. The periodic table is a rectangular arrangement of numbers in groups and in periods. They will ask you. So if you are to define periodic table, it's what? A rectangular array of elements, okay, in groups and periods. You can see rectangular arrangement of what? We are come to arrange elements in groups and periods. We won't minka. Linda, can't you say this?
Yeah, I wanted to say it before you said it.
Oh, next time I'll shut up. Okay. So, Andrews, are you following? These are questions when you are being asked. You should be able to answer them. You should be able to flow. Am I reading textbooks?
Okay.
Am I reading textbooks to you? Hello, am I reading textbooks to you? I'm not. So it should tell you that you can just, these are like something petty you should be able to do. Anyway, so let's start. Group 1 will be hydrogen, right?
Yes.
Yeah, so hydrogen is here. Are you with me? I don't have space, so I'll not write the chemical symbol. Then group 8 will be helium. Okay, that's how we start. You put helium as group 8. So then now you can now flow from period 3. Lithium. Don't you know what are the first 20 elements?
I believe you
Beryllium. I think beryllium is 1 arrow. When you check, I think it's 1 arrow. See, when you check, whatever you see is right. Leave me alone. Yeah, beryllium, boron. Uh-huh. Carbon, right? Nitrogen. Monkwe. Monko school on.
Oxy.
Oxygen. Arrange them under the groups. Fluorine. Yeah, I forgot him. Venice. After fluorine, neon. Yanko. Sodium, magnesium, aluminium, silicon, mm-hmm, phosphorus.
Silicon.
Ah, what I've said already. Phosphorus, sulfur, uh-huh,
Chlorine.
sulfur, chlorine, okay, chlorine, uh-huh, argon, right? Finish up, guys. They are waiting for me. Can you see the screen?
Yes.
This is the first 20. Then we go to scandium, titanium, vanadium, chromium, like the from 21 to 30. Yeah, I mean, you meet copper, zinc. Zinc is the 30th. So we are come to talk about this. This is done in a chronological order, okay? This is element number one. Helium is element number two. It's not done in any different order. It's in a chronological order from first to last. Lithium is three, like that. Beryllium is four. Ordinarily, if I had the space and time, I would have written their symbols. Oxygen is eight, fluorine is nine, you know. Guys, are you writing?
Yes.
You when you're done, let me know, because we have a lot to say about this. Sodium is 11, magnesium is 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17. I'm coming here will be 19, here will be 20. I'm not come to shift. Argon is 18. I'll reduce the font for you to see everything in full. Uh-oh. Oh gosh. Mm-hmm. I'm waiting for you. Now, I'll come to show you how to know or identify metals and then how to know their charges. Okay. Now, in the periodic table, or so when we talk about group refers to the vertical arrangement of elements. Okay, in a periodic table. So when I tell you to list all the elements in group one, I want you to go vertical. So we are looking at hydrogen, lithium, sodium, and potassium. Dennis, can you tell me the elements in group four?
Carbon, silicon.
Carbon and silicon. My goodness. In our previous recording, I made a mistake. Okay, no wonder I placed an asterisk. I said the semi-metals are silicon, germanium, right? And I said boron and I placed an asterisk. I wonder what I was thinking. I wanted to say carbon rather. It's carbon, no boron. I wish I can correct that. But if you listen to the audio, I sounded very unsure. Yeah, I said look it up. It's carbon I wanted to say. Anyway, yeah. So now all metals lie from group 1 to 3. So metals are in group 1 and group 1 to group 3. So group 1 elements are metal, group 2 elements are metals, group 3 elements are metals. You got it? So you must be able
Yes,
to
sir.
visualize a periodic table. You can draw it yourself. Just know the first 20 elements, right? So there you go. So you have hydrogen, lithium, sodium, potassium, beryllium, magnesium, calcium, boron, aluminium. I've I've made you try aluminium and magnesium, right? So meaning there are a lot for you guys to do, right? I can give you calcium, I can give you potassium, lithium, and what have you. So all elements in group 1 to 3 are metals. Are you listening? Now, if you are in group 1, meaning your charge is +1, there is a way to calculate charges, but to make it easier for you, if you're in group 1, you see charge, charge, there should be a sign. So if you're in group 1, your charge is +1. If you're in group 2, your charge is +2. If you're in group 3, your charge is +3. Simple. So if I tell you what's the charge for calcium, calcium is in what group? Group 2. So it's +2. Simple. Right? There is an in-depth explanation to this. We use the electronic configuration and what have you. It all comes down to this. So keep this in mind. So what's the charge for lithium, guys? What's the charge for lithium?
+1.
Yep. All elements in group 4 are semi-metals. All elements from group 5 to 8 are non-metals.
That means group 5 to 8 are.
Non-metals. Remember, we are talking about groups. We are not talking about periods. Non-metal. Group 5 to 8. Semi-metals. So at least, if I give you aluminium, what you need to know is to know the group. Once you know the group, you'll be able to tell the charge, right? +3. So it will help you to cross, interchange them. If you have any question, ask me now. All elements in group 7 are called halogens. All elements in group 7 are called halogens. So, Linda, give me an example of a halogen.
Chlorine.
Yeah, so we have chlorine, fluorine. We also have bromine. Other examples are bromine, iodine. You even met them. I wrote Br2, I2. Yeah, so that's it. Oh, sorry. This bromine gas. I'm sorry. Br bromine. Iodine. All elements in group 8 are called, yes, anyone to try. It's common. All elements in group 8 are called inert gases or noble gases or rare gases. inert or noble or rare gases. So we have helium, neon, argon. Okay. So another example is xenon. The chemical symbol is, no, I didn't spell that well. It's X. The chemical symbol is X, xenon. Now you are in senior high school. You should not settle with just the first 20 elements. At senior level, you must know from number 21 to 30 offhand. 21 to 30. I said scandium, titanium, vanadium, the rest. I don't know the order they follow. But you meet nickel, copper, and what have you. Go and learn that. You must know that offhand. So zinc is there. Okay. Zinc is the last one, number 30. You must know 21 to 30. Now listen, the elements from number 21 to 30 are called transition metals. So go and learn them. What matters to us? So all the elements from atomic number 21 to 30 are called what? Guys, are called what?
Transition metal.
Transition metal. And I just told you zinc is number 30, right? So our
Yes.
index in the word what? Metals. It's a transition metal, all the elements. So if you know them, then you know transition metal. So this explains why in our main setup for hydrogen gas, you see zinc at the bottom, and I said it's a metal, right? Zinc is a transition metal. Every metal is a metal. I don't want to load you much with information, so I'll leave you here. But the goal has been achieved. Now you know you'll be able to identify acids. You'll be able to identify metals. So, and when it means you marrying them, you can tell the charges. If it's a radical, you know some common radicals. So you can tell they are charged. And then if it's a metal, you know they are charged, right? So go and learn about transition metals. I'll ask you to call them out in our next meeting. Now, as you are going home, go and react potassium. Go and react potassium and sulfuric acid. Go and react. Now, potassium, if you look at the periodic tables in group 1, it should tell you it's a metal. If you look sulfuric acid, you know it's an acid. So, you know, an acid reacting with a metal, hydrogen gas will be produced. Are you there?
Yes, sir.
How about the rest? Come again.
Yeah, okay.
There's one more thing we are going to do to wrap up. Right. Test
Next one.
for hydrogen gas.
Say assignment.
No, we are doing a test of or what? Test for hydrogen gas. It's a question they'll ask you. We are preparing a gas. Now, in the inverted beaker, cast your mind back. In the inverted beaker, we are concluding hydrogen gas is prepared, right? how would you know in the inverted beaker the gas there is hydrogen gas? When you are making stew, you use tomatoes and what have you, the paste and stuff. How do you know that the end result is tomato stew?
When you add tomatoes to
Say that again. You are having a video call with me, you're teaching me how to do that. I would mean. You are teaching me how to prepare rice. So you tell me, get some rice, pour some water. I've done that, everything, salt. It's on fire. Leave it on fire for a while. I say, okay. Some minutes later, I turn the fire off and then I call you to. So I call you to ask you, how will I know the food is prepared? You know, some cultures you don't know rice, right? Some cultures don't really eat it, so they don't know how it's prepared, right?
yes.
Yeah, so like we eat it, so we know how our meal is prepared. So like assuming you a foreigner and you're teaching me how to make one of our local delicacies and you guiding me. Now I'm down. Now how will I know it's rice prepared? So how do you talk to me? What should I look for? How will I know it's rice prepared? Yeah.
So the ingredients.
Say your ingredients.
What be that? Monte question last year. What kind ingredient you actually me? What's it? Koto rice, my koto jasmine, my koto salt. And I made rice, egu in swam right. And I'm this salt and I then egum fine. And I'm also just so. Okay. You hang up the corn and then 5 minutes later, Masawa before say, and Sisiano, Mary Medum fire no. Mad and who say I'm rice no, near rice water. How will I know?
The appearance.
And see a bill who saying,
Just rice water. No.
made rice and I mean you and your rice pudding. So how will I know say rice and my yeah? So what would you tell me to be looking for? I don't know where the
Say you put on the rice, I've been and I am there.
and where they who say rice and abbing, where they who say rice and abbing and the Mayan and rice and Mayan.
There's so much to say, yeah.
Ah,
And the answer
yeah, right. I am so when you are now saying friendly. I have to also check in so nas like in so no
Exactly.
yeah. You get a point here. So yeah,
Yes.
that's even solid though. Sorry, like solid liquid kind of stuff. Now we're talking about gas. And look, there's a setup. Setup, gas and gas cannot be seen. I would mean. Sure, gas will be beaker no cry. I don't know. And the beaker is what's inverted. Now, how would we know that the AI is gas and a strong and say gas? How will we know a hydrogen gas? And see, I know the baby. So now so that's what you do. Now you have to get a flame, okay, a glowing splint. When I talk about a glowing splint, something like what those that smokes use to rekindle their cigarette, lighter. I would mean
The lighter.
lighter, and so me up in a jaba. So a jano na your friend or glowing splint. Okay, I'll write it for you. So bring a glowing splint closer to the beaker containing the said gas, the unknown gas, the gas you're testing for. Now, so if you bring the glowing splint to the beaker containing the gas, and indeed the gas that is prepared is hydrogen gas, it gives a pop sound. If you bring the flame to that container containing the gas you prepared, you hear pop. Do you understand? Once you hear po, the meaning the gas there is what? Hydrogen gas. So you've learned how to prepare the gas. How do you test for it? How do you test for the gas? So that's what I've taught you, right? So let's write. So what I'm saying is that introduce a glowing, right, splint to the container with, or let's say to the beaker. Don't worry, we are closing. To the beaker with the unknown gas. Right? That's the first thing you do. Then the next one, gas gives or gives a pop sound. We are done. So that's all, guys.
But there are many ways to test for hydrogen gas. Only this
This is the
way.
only way. Well, I do not know if chemists have a different approach, but this is what is in the syllabus. This is what I'm even used to.
The can you do some of the experiments in your office?
Come again?
Can you do some of the experiments in your office?
Yeah, but the time factor.
No, like next time.
Yeah, this is not the only experiment we are doing, because apart from hydrogen gas, you see, I gave you other gases. The ones you were highlighting, upward delivery, downward delivery, and stuff. Okay, we'll touch on a number, not everything, but a number of them, the examinable ones. So, by the way, now you've gotten to know that hydrogen gas is prepared using what? Upward delivery. Do you understand? Upward delivery. Now, the next question to ask you is uses of hydrogen gas, physical properties of hydrogen gas, chemical properties of hydrogen gas. So that one, I want you to go and look at that. From user approaches, if it is there, a good Samaritan can take a picture and send it to the school page. Uses of hydrogen gas and properties of hydrogen gas. Okay, properties. And you see, it's important because in the exam, when they draw the setup for you, these are the questions they will ask you. Who has the approaches? I used to have one, but students come for it and never return them.
That one.
Oh, good. So if it is there, then send us a picture. Okay. Very nice picture. And you people, when she does so, right. Do you have any question?
No, sir.
How to like the channel and subscribe to it. See you guys again.
Okay.
Oh.